Hi, class 12. So let's continue our class. So far we have done cell EMF internal resistance. Okay. So to understand next topic, we'll start on page number 113. There you have cell in series and in parallel. Okay. So to understand this, first we'll look about this rule. Okay, or law. So write down Kirchhoff's rule. Kirchhoff's rules. Okay, or you can say law, no problem, isn't it? It will not change, isn't it? Law and rules never change, but in chemistry you have theory, isn't it? Bohr's model, like those are the theory will change, isn't it? So law will not change. So physics is definite law. Okay, or phenomena. So first, there are two rules in Kirchhoff's. Okay, Kirchhoff mentioned two rules. For why he mentioned? Because see, you know this one, isn't it? You can find the resistance of this type of connection, isn't it? But if I have, there is cell resistance, cell, so resistance. So again, if you have cell, then you cannot find this type of the current through this particular connection, isn't it? Okay, circuit. So to solve this type of circuit, we have Kirchhoff's rule. Okay. So just listen, okay, then you'll understand. Okay. So to solve this type of circuit, you have, see, this one is simple, isn't it? Series R1 plus R2, isn't it? So parallel 1 by R1, isn't it? So, but if there is a complex circuit, then you won't able to solve whatever there is. Okay, current, voltage, or resistor. So Kirchhoff made rule. Okay, so first write down Kirchhoff's first rule. Kirchhoff's first rule. So Kirchhoff's first law, or you can write a rule. Then you also, this is also called junction rule, and this is also called Kirchhoff's current law. Okay, Kirchhoff's current law, KCL in short form. So first write down. Okay, so at any junction, I will tell what is junction. Okay, so at any junction, at any junction, the sum of current at any junction, the sum of current entering the junction equals to the sum of current leaving the junction, or that is also you can write at junctions the sum of current equals to 0 at junction. Okay, at junction sum of current is your 0. So next write down principle. They may ask in 1 marks. Okay, on which principle this law is based on. Okay, so write down the principle is, it is based on the principle of conservation of charge, right? Conservation of charge. Second rule or second law is based on conservation of energy. Okay, this one is your conservation of charge. So first we will discuss with junction. What do you mean by junction? So write down junction is that point, okay, of a circuit where three or more wire or conductor met. So this is your one type of meeting point, isn't it? So this is called less than 3, isn't it? So this is your node, and junction is this one. See, 3 lines are there, isn't it? So this point is your junction. This point is what? Junction. Clear? So if I say this 5 ampere and this is 2 ampere, then this rule says that the sum of current entering the junction, how much? 2 plus 5, 7 is entering. Now what should be the current here? So that should be 7. Why? Because equals to the sum of the current leaving the junction. Clear? So यो दुईटा जोडेर त्यति नै निक्लेर जान्छ. This is very simple, isn't it? Alright. So but if I have not understood junction also, this is your junction. Now see, if you sum the current, so entering how much? 7 ampere, leaving 7. So sum equals to how much? 0, isn't it? Leaving means minus, isn't it? So sum is 0. If there is minus sign, then the direction should be opposite. Current को direction कस्तो हुन्छ? Opposite हुन्छ. त्यो पनि याद राख्नु. Okay. So how you will understand that point is that, see, if I say this is my 2 ampere and this is my 3 ampere. Clear? So and this is also going out from the junction, isn't it? Coming, and this is your 5 ampere. Sorry, this is your 8 ampere. Then what should be this? This should be minus of 3 ampere, isn't it? So current kata आउनु पर्यो? Minus, isn't it? Clear? So direction, the sign gives you the direction of current. So entering in a junction equals to the going out of the junction. So next you have Kirchhoff's second law. Write down. Then this much. So write down second law. Kirchhoff's second law. This rule is also called loop rule. Okay, and this is called voltage law. This is called voltage law, Cbse. Okay, short form. So second law. So first write down the algebraic sum. So law is here, the algebraic sum of charges, okay, not changes, charges in a potential, in potential around a closed loop is 0. So what it means is that del V equals to how much? 0. Sorry, turn page number 116. There you have loop rule. Okay, the algebraic sum of changes, okay, not charges, changes in a potential around a closed loop is your 0. So del V equals to 0, or you can write this as closed this means close, okay, close, any figure closed, okay. So plus minus v1 plus minus v2 plus minus dot 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 plus minus vn equals to almost 0. So what it means is that algebraic sum, isn't it? If you add the potential drop and potential gain, isn't it? In a closed surface circuit there is potential drop, isn't it? Current coefficient potential drop. So write down potential drop. You have to take negative, okay. So and potential gain you should take positive, okay, clear. So this would be minus of v, this would be plus of v, clear. So now next write down principle on which it works, okay, it is based on, okay. So write down principle, it is based on principle of conservation of energy, because energy never be created nor be destroyed, but it can be transformed, isn't it? So this is what, isn't it? So now next write down how to apply Kirchhoff's law, clear. मजाले लेख पहिला rule law भनेको एउटै हो, okay, but theory will change, isn't it? Just atomic theory changes, isn't it, with the time, but rule cannot change, okay. It is a universal truth, isn't it? So write down how to apply Kirchhoff's rule. How to apply Kirchhoff's rule. So write down how to apply. अब यो त rule त पढ्यो. So how to apply. These are the step, okay. How to apply Kirchhoff's law, or you can write rule, clear. So first step you have to go with junction, okay. So draw current from, draw means you have to take your current from any circuit, okay. Current from, there are two or more cells, isn't it? From one or more or two, you can write cell, okay. Draw current, okay. Then you have to follow KCL, current, that is your junction, for distribution of current. Distribution of current. Clear? So what that means is that, see, I is coming, entering the junction. This is the junction, isn't it? And I is entering the junction, then this is your I1, then this should be how much? I2 equals to how much? I minus I1, isn't it? So you have to follow the KCL. Next, what you have to do? Second number, choose a loop, isn't it? Second is your voltage, isn't it? Choosing a loop. Choosing a loop. How you choose the loop, isn't it? Loop means when you start from one point and comes into the same point, that is your loop, okay. So loop should be how much? Should be closed. Open हुनु हुँदैन loop चाहिँ, okay. त्यहाँ बाटोमा छोडिनु हुँदैन. So loops, closed loops, okay. Closed loop or loops, clear, can involve any number of cells, can involve any number of cells, resistor, etc. Capacitor, isn't it? So first we'll do cell and resistor, okay. Capacitor is there. Third third step is your direction of loop. Loop को के भन्छ direction of loop. You can take, or this is also called path. Okay, direction of loop लाई के भन्छ path also. So you can do, one is your clockwise, second is your anti-clockwise. Clear? एउटा यस्तो घुम्छ clockwise, अर्को यस्तो घुम्छ, loop को path, isn't it? Next, potential drop. Fourth step is your potential drop. How you'll show the potential drop, isn't it? So fourth is your potential drop. So higher to lower potential, what you'll get? Potential drop, isn't it? Potential drop, that means negative, isn't it? Yes or no? So del V equals to negative. So higher to lower. त्यसरी नै lower potential to higher potential gain, isn't it? So del V equals to how much? Positive V. So lower to higher, positive. Clear? So this is your potential drop. Now just see your cell, isn't it? Cell is there, isn't it? So this is your cell, or cell. So this is our cell, isn't it? Internal resistance is there. So this is your at higher potential, and this is at lower potential, and this is the path of your loop, isn't it? Clear? Yes. So potential you should take del V equals to change in potential higher to lower, how much? Negative of E, isn't it? This is the potential of cell, isn't it? EMF. Clear? So if I have another path, then this would be how much? Positive, isn't it? Lower to higher. So del V equals to positive of EMF, isn't it? Epsilon. Likewise, resistor. This is path. So resistor, this is your resistor. So current flows from higher to lower, isn't it? So what happens in resistor? See, higher to lower, how much? Potential is your negative, isn't it? So potential del V equals to how much? Minus of IR, isn't it? Resistor, current into resistance. Likewise, this is the path, same, isn't it? This is the path of your loop. Next, if I have path is different, then lower to higher. So what happens? What happens? Del V equals to how much? IR, positive, isn't it? Like, so this is vice versa. Sorry, high to low, negative, low to high, positive. Clear? So just remember this too. So let's solve one question for this rule. Okay, मजाले हेर, copy गर, then only you will understand the circuit. Okay, complex circuit will come, isn't it? त्यो simple आउँदैन, तर हामी के गर्छौं, simple बाट गरेर तिमीलाई complex पनि बुझाउँछु ल. So you know that, see, this is our let's say this is cell, how much? 10 volt. Clear? And this is resistor, and this is also resistor. 2 ohm and this is your 3 ohm. Clear? From class 10 you can solve, isn't it, from that part. So what is that? So you have to find R equivalent equals to how much? Series, isn't it? So 2 plus 3 how much? 5 ohm. So question also, find the current. Find the current through each resistor. So current through each resistor, current the same, isn't it? So first equivalent resistance. So current how much? V equals to I R. So I equals to V by R. So V how much? 10, isn't it? V is your 10, R is 5. So current equals to how much? 2 ampere, isn't it? 5 2s are 10. 2 ampere. Clear? So this is our class 10 standard, isn't it? But this can be solved by Kirchhoff's law also. Okay, what is that? You have to take a loop, isn't it? So A B C D. Clear? This is a loop. So write down loop is your A B C D. A लेख्नुपर्छ. ओके, यही आइपुग्नुपर्छ, त्यहाँदेखि मात्रै लुप हुन्छ. यहाँसम्म लेख्नु हुँदैन लुप. कस्तो लिउँ? डाइरेक्सन अफ पाथ क्लकवाइज. ओके, दिस इज द डाइरेक्सन अफ पाथ. हामी यताबाट जाँदैछ. सो क्लकवाइज. क्लियर? सो यहाँ हेर के हुन्छ, यो नेगेटिभ टु पोजिटिभ. पोजिटिभ हुन्छ. सो 10 भोल्ट, इजन्ट इट? अब यस्तो आएर यहाँ कति हुन्छ? दिस इज द पाथ, इजन्ट इट? सो यता जाँदा के हुन्छ? यो हायर टु लोवर के हुन्छ? नेगेटिभ, इजन्ट इट? हायर टु लोवर अघि गरेको नि. दिस इज हायर एन्ड दिस इज लोवर. सेलमा के हुन्छ? उल्टा हुनसक्छ सेलमा हो कि. पहिला यो बुझिहाल. हायर टु लोवर. सो नेगेटिभ अफ आई how much? I R. R is how much? 2, isn't it? Next same minus I. I त जाँदैछ, isn't it? So I त खोज्नुपर्छ, isn't it? 3 equals to 0 हुन्छ नि त. यो लुप रुल, isn't it? So how much? 10 minus 5I equals to 0. So minus 5I equals to 10. यो उता जाँदा माइनस, isn't it? 10 उता जाँदा. So minus minus cancel. I equals to 10 by 5 equals to 2. Again I equals to how much? 2 ampere. Clear? This is what the Kirchhoff's rule, isn't it? दुईटा रुल लाग्यो नि यहाँबाट मैले ड्र गरे करेन्ट, isn't it? डिभाइड भएको छ. नो, दिस इज नट अवर जङ्सन. दिस इज नोड, isn't it? नोडमा त सेम जान्छ. सो देयर इज नो जङ्सन. सो आई रिमेन्स सेम. यता पनि आई. So I. So V, you should negative to positive, higher to positive. This is your higher level to lower, minus minus. So this happens. Okay, today this must solve it and show me on Monday or tomorrow. Okay, so thank you for today for this Kirchhoff's law. Then we'll do complex like this. Okay, अघि भने जस्तो गर्न सक्छ. So this much for today. Thank you.